Okay, practical problem. You work for the county planning department and you need to help them decide where they're going to put in a new sewage treatment plant, right? So think about the kinds of things that we need to consider when we're putting in a piece of infrastructure like that, right? There are certain things that you want to definitely have, there are certain things you're going to want to avoid, but let's kind of think through what some of those things are going to be. First of all, sewage treatment, I think it's safe to say one thing that we don't want with that sewage is for it to get into a stream. So let's start off with, and by the way, this is a vector coverage that we have for streams. We have an area where we know we've got a couple of streams in the area. Let's say this is kind of the general vicinity of downtown Hilo, right? So automatically we know we don't want that to be within a certain distance of the stream. So what are we going to do? First type of analysis, we're going to set up a buffer. And let's say that buffer is 500 meters, right? There may be some state regulation that means that it has to be that distance. So we go ahead and set up that buffer, right? That would be a distance of about 500 meters, and we go ahead and calculate where those areas are that are within 500 meters of the stream, okay? So those are the areas that we do not want. So what I'm going to do is I'm going to shade in the areas that are not inside that buffer to cover the areas that we do want. So I'm going to go ahead and put this blue hatching to show these are the areas that are okay as far as where the streams are to put a sewage treatment plant. So all these areas that are not inside that buffer are totally fine as far as putting in that sewage treatment plant. Okay? But that's just one thing, right? We have streams. Turns out there's some other things that the county has that they didn't necessarily design based just on that one thing, and that's zoning. We have to have an area that's zoned either commercial or industrial. And it turns out when you look at a zoning map, it's kind of this mixture of different areas, and they're based on straight line boundaries, right? So let's say we have an area kind of through here that's zoned industrial, right? So that's going to work. Everything inside this square that I've just drawn. There's another sort of commercial / industrial area over here, right? So those are a couple of areas that work in terms of setting up the zoning to be appropriate to that land use, right? Maybe that there are a bunch of homes and things in these other areas. You don't want to put a sewage treatment plant in a residential area or an area that's zoned for residential use, right? So you want to have that in place. So those areas, and I'm going to go ahead and draw them with a red hatching in the other direction, just so we can kind of see the overlap between those two, right? Okay? So we'll go ahead and put those in, again, in a different direction so that it really shows up. And so what you're starting to see is there's some areas that fit both of those two categories, right? They're not too close to a stream, but they're within the area with the appropriate kind of zoning, right? So the final thing is that in order to do the sewage treatment plant, of course, we need to be able to tie into a main water line, right? So this is going to be another line vector coverage, right? This is a a vector polygon coverage. These are polygons, they're very simple polygons, they're basically squares. But let's say the main water line happens to go through, and it goes through something like this, right? So there's the main water line, and we need to have it really close to that main water line. So we're going to set up an even closer buffer, a buffer of 100 meters, right? So that's going to be a lot closer to that water line, and I'll draw that buffer like this. And now I'm just going to draw this kind of in a hatching in this direction. Now you can see that very narrow area that is close to a main water line and where it overlaps with the others, right? And when we stack all of these together, and that's what polygon overlay is doing, basically we're going to find that there are only a few areas that meet all three of those criteria. Notice for this buffer I hatched the inside of the buffer, meaning we need it to be less than 100 meters from that main water line, whereas with the stream we did a buffer on the outside to say I want areas that are more than 500 meters from the stream. And so you can see we have areas where we meet a couple of the criteria over here. We have all these areas that don't meet any of the criteria. This area, that little sliver, meets 2 of the criteria, but the only area that meets all 3 of those criteria is this area right here. And I'm going to draw it in extra thick black marker just to show, right? So that's the area. It has the zoning, right? And so you can see part of its boundary is the zoning boundary. It has the appropriate distance from the stream, right? It's more than 500 meters from the stream. And it's within 100 meters of that main water line, right? And so this is basically going to be our candidate area for where to put that. Again, you could imagine adding more and more criteria. Maybe you need to be a certain distance from power lines. Maybe you can't be a certain distance from a school. Maybe you have to have a certain kind of soil that's deep enough so that you can put in those new big pipes so that they're buried underground, right? There are all kinds of things that we could add to this. We just use three criteria by overlaying all those pieces of, in this case, vector data, and then adding in some intermediate analyses in the form of making those buffers. We can basically narrow it down to a very small area, solve that problem, and the county can choose the best place to build that sewage treatment plant.